So my talk is about going fully modular with Walibot. And I want to start my talk with a little question. What do you think is the average amount of JavaScript that gets downloaded when you open a modern website? So how many kilobytes? 1 megabyte? Someone else? 600? Ooh, seems like you already saw my slide. Okay, we have a slide here that basically shows how the bundle size evolved over the years. And what we can see that we currently are at an average of around 600 kilobytes. And if we look back around here, so 10 years ago, we were at about 200 kilobytes. So in the last 10 years, we saw an increasement by 3x. And why are our websites getting bigger and bigger? The question or the answer is pretty simple, because we add more functionality and more features, especially over time. But I think there is another answer, and that's related to the architecture of many libraries and frameworks we are using. Some of you might think, why bother? Why bother because of a few hundred kilobytes? And that's maybe true if you have a perfect connection and if you have a strong computer. But we probably all know, especially here in New York with the subway, that websites can take seconds to load and sometimes even longer to get interactive. And in the end, a slow website and a long loading time leads to a bad user experience, and that leads to less usage, to less conversion, and to less sales. And beside of the financial aspect, we also don't use our resources in a good way when we ship more than necessary over the internet. And that's why my talk will focus on software architecture. And I want to have especially a look at bundle size. But before that, a few words about me, because I'm not that famous like Rich or Misko. My name is Fabian. I'm a student here at PACE, like probably most of you. In the past, I founded 2 companies, and I also produced tutorials for Heise Academy, where I teach HTML and CSS. Heise Academy is probably the biggest IT publisher in Europe. And I also appeared several times at the Programmierbar podcast, where I talked about React, Next.js, Solid.js, and also about Quick. The Programmierbar podcast, I think, is the most popular German podcast on web development and app development. And nowadays, besides my studies and besides all the other stuff I'm doing on the side, I'm an open source maintainer. And my biggest project since a year is now Walibot. Walibot has now more than 6,000 stars on GitHub, and we just passed 1.5 million monthly downloads. And as you can see, we are growing. And what's even more surprisingly for me to see is that on another package registry on Dino/X, we are the 3rd most used package from more than 7,000 packages, and we are even on a better place than the SDK from OpenAI. And this shows me that I think we are going in a good direction and that Walibot hits a pain point. And I think it's important to say that we are not in V1 yet. We are not officially stable, but we are already in beta, so we will get there soon. What's maybe a little bit special about my open source project, it is based on my bachelor thesis I wrote last year. And in my bachelor thesis, I investigated the implementation of a modular schema library in TypeScript with focus on bundle size and performance. And my bachelor thesis, I was lucky, was supervised by Misco and also by Ryan Caniado, the creator of SolidShares. And it's interesting because I also have a kind of academic relationship to Rich because as part of my bachelor, I also wrote a little paper about Svelte versus React. The main finding or the first finding of my bachelor thesis, so basically that was part of the motivation why I wrote the paper, was that most websites and most libraries and frameworks ship more than necessary. They basically ship dead code. That's basically code that is never executed and kind of useless. And that you don't have to trust my words, I will give you a short demo. So what we probably are doing when we want to add a new feature to our website, we of course don't implement everything ourselves. Instead, we go on NPM or another package registry. And a common functionality in many websites nowadays is schema validation, for example, to validate forms. And that's why we type TypeScript. Oops. And because we want to use what most are using, we choose SOT. And I already prepared a little demo where I have imported SOT on line 1, as you can see here. And then I used SOT's string function to make sure that our input is a string. And I also used a method called min, and we can use that to make sure that a string have a minimum length of 5. And then I used the schema and used its parse method to parse a string with 3 characters. And if we now execute that, of course, we get an arrow. And the arrow is telling us string must contain at least 5 characters. So that's basically what we expected. And if we now copy the entire thing to Bundle.js, that's a website where you can bundle your code. It uses ESLint under the hood. And we run it. We will see that kind of these 2 lines costs us almost 13 kilobytes. And I also implemented the same functionality without any library, so basically with raw JavaScript. And so we have a function here called string2. It expects an unknown input, and then it checks in a first if condition if it is not a string, and if that's true, it will throw an arrow. So if it is a string, then it will continue, and then it will check for its length. And here it will also throw an arrow if the length is invalid. So basically almost the same functionality that we had with SOT. And if we run that now too, no, then of course we also get an arrow. But if we now copy this over to Bundle.js, you will see it will cost us less than 130 bytes. Oops. And that's a reduction in bundle size by 99% compared to SOT. And that was just one example. We could go on and, for example, want to add the functionality to format a date. So we type format date. Oops, that's not right. And then again, we choose the most popular solution that's currently Moment.js with 20 million weekly downloads. And if we format a date with Moment.js, it costs us 20 kilobytes. And that's basically just one line of code here. And 20 kilobyte that's coming from the library. And I could go on and on and on with small little functionalities, and you will see we will quickly end up at like 100, 200, 300, 400 kilobyte of JavaScript. Even the raw functionality we need is just a few hundred bytes. So why is that? And the answer to this question is probably because how these libraries export their functionality, but also it's related to how the source code is architectured. In case of SOT, it's implemented object-oriented, and that's probably how a lot of us write code, because that's usually how we learn to write code. And in SOT's case, that's like a minimal reproduction of the actual code. The string function internally creates a new SOT string, that's a class. And this class has many methods. For example, a method to validate email, emoji, and also the min and max length function we already saw in our code. And this class inherits from another class called SOT type. And this class adds even more methods to the bundle. And the problem with this approach, it's not tree shakeable. And Jared Palmer summarized it perfectly in a tweet last year. And some of you may wonder what's tree shaking. It's a technical term in JavaScript that basically describes the process of a bundler to analyze the static import and export statements and basically removes everything that is not used. So in really, really simple terms, it grabs your tree of dependencies and shakes it and only keeps stuff in the bundle that you actually use and have imported. But the problem, for example, with SOT or with an object-oriented approach, it can't tree shake methods. And to solve that, we need to export every functionality on its own. So instead of writing a class with many methods, we write many functions for every functionality our library contains. And you may wonder now, why is that not the default if it is so much better, especially in terms of bundle size? And there are, again, probably a few answers to that question, but I think the first most important one is implementing a library, for example, object-oriented, is easy to get started. You create your first class, you add properties to your class, you add methods, and you expand it as you need it. And that's a little bit different with a modular architecture, because with a modular architecture, you can't simply access object properties or other methods that are part of the class. You need to figure out how you exchange information, how you exchange functionality. So basically for a modular architecture, you need a big picture from the beginning on. You need to know how each component plays at the end together. So to get started is maybe a little bit more difficult, but more about that later. Another reason, of course, is the developer experience. I think all of us that already used SOT loves its DX, and that's probably one of the most important reasons why it's so popular nowadays. Because in SOT, you can simply chain the methods, and if you use TypeScript, TypeScript already knows what methods are available. That's why if you know like the basic data types, you not really need a documentation to get started with SOT. And if I'm honest, it's hard to get at the same developer experience with a modular architecture, but I think we can get close. And to get close, we need a really, really simple but also strong mental model. That's just a slide from the Walibot documentation. There is a dedicated guide if you are interested in that. And of course, we also need a great documentation, and that's basically where Walibot and we as a project put in a lot of effort. So now, are there any alternative solutions to a modular architecture? And probably yes. One would be a compiler that goes beyond what we nowadays have with tree shaking. But the problem is JavaScript is a highly dynamic language. So you can dynamically access properties. And if a compiler would, for example, remove object properties that are not used, then it may change the runtime behavior at other parts of your code. For example, if you read out the number of properties, stuff like that. And that's why it's a harder problem, and I'm not aware if anyone succeeded yet with that. Another option would be a compiler for every library, a little bit what we have with Quick and Svelte. But that's probably not the right approach if you implement an API SDK, because it's complicated to write a compiler. And I think your users are also not interested to configure a compiler for every library they are using. Now I quickly want to summarize a few benefits of a modular architecture. I said that it's probably harder to get started, but I think once the basic structure of a modular architecture is established, development gets much easier. And that's because these small functions only cover one functionality. And if you write a class with methods, they probably cover a lot. That's why a single function in a modular architecture, like what I did with Walibot, contains only a few lines of code. And these functions also do not access some outer properties or things like that, what you often do with classes. So it's a lot easier to follow. And what's also easier, it's a lot easier to test them in isolation, because it's only a small functionality. And because you export everything on its own, you are also completely free on how you kind of structure your project. You can kind of put these functions everywhere. It's a little bit harder to, or not possible to split a class. And beyond that, another cool thing with a modular architecture, if you use a library with a modular design, but a specific function don't work as you expect, you can just replace it. But I think it's a little bit harder to replace a method in a class. And yeah, and there's probably more you can do to improve your bundle size, for example, minification and compression. And if you are interested in more details, feel free to read my thesis. And with that, I want to talk a little bit more about Walibot. Walibot is a schema validation library. You can use a schema to define a structured dataset. For example, a dataset for your login form with an email and a password. And then you can use the schema to infer its TypeScript type information. And you can also use it to validate data. The magic here is that a schema is the single source of truth for both the types and the validation logic. And because I know that may sound confusing if you never heard or used from a schema library, I want to make a quick demo. So, Walibot's website ships with an entire code editor. So you can just go there, create your schemas, and then run them. And that's basically what we're doing. We start by creating our first schema. And the schema in Walibot starts with a schema function. We have more than 40 schema functions for basically any data type you can imagine, for strings, numbers, object arrays, map set, basically everything you may have in mind. And we want to start with a string. And a string, so the schema validation functions, they validate a data type. But often we want to go beyond. We want to validate the formatting, for example. And we can do that in Walibot by using its pipelines. So we just write v.pipe. We add our schema as the first argument, and then we can add further validation and also transformation actions. For example, we can write v.email, and now our schema is validating if something is a string, and if so, it checks if it also is an email. And the cool thing here, it synchronously goes from left to right. So it starts with string and then continues with email. And pipes are extremely powerful because you can also do transformations. For example, you can trim your string before you check if it is an email. To continue this demo, I jump to my next tab because our time is limited. And here I prepared a little example. I again created a schema, but this time it's a more complex schema. It's an object with two properties, an email, and a password. And basically you can see what we already saw in the previous example. We use pipe and, for example, make sure it's a string and that it's also an email. And now we can use this schema together with our save parse method to validate unknown data. And the save parse method will then return a result. And you can use this result to check if the validation was successful. And in this case, in case it was successful, we can log its output to the console. And what's cool with a library like Walibot or also SOT, the output is fully typed. So the library kind of knows if or TypeScript knows if the validation was successful. It will always return an output that's an object with two properties, email and password. And if the validation was not successful, we can access its issues to see what went wrong. And what's special here about Walibot, even the issues are typed. So for example, if I access the type property of the first issue, we will see it can only be of type string, object, email, and min length, because that are the only schema functions and also validation actions we used. And now let's run this code to see what it's doing. And as expected, we get the output because the input was valid and matched with our schema definition. But if we now remove a character, so it does not match now with what we defined here, we expect an error. And that's basically what we are getting here. And the cool thing with the errors with the issues in Walibot, they are completely uniformed across the entire library. And for example, here you can see it is of kind validation. You can see its type, so what produced the error, and you get a rich error message that tells you invalid length, expected greater or equal 8, but derived 7. And what's even cooler, it also shows you the location inside of your complex data where the issue is located. And you can use this path information, for example, with a login form to show the arrow at the password field. And the last thing I want to demonstrate is if we now copy over this code to bundle.js and run it, you will see that it costs you a little bit more than 1 kilobyte. And to come now back to the start of the presentation. I don't think we should go back to 2014 in terms of functionality and features, but I think we can go back in terms of bundle size, and maybe we should. And with that, thanks a lot for your attention. Do you have any questions?
I was gonna ask, I know TC39 is possibly working on the pipe operator. Well, at least like stage 1, stage 2, I don't know where it is. But if it does ever become standard in the future, how do you feel Valib.'s API will change as a result of that?
I'm not sure if our pipe feature will change because it works a little bit custom under the hood. And I had a look at the proposal once, and at this time, it seemed like it will not change anything because it will probably not be compatible with what Walibot is doing because under the hood there happens a little bit more. And I'm not sure if that can be implemented with this new feature. But we will see.
In my previous company, I used to work like as a software front-end developer. And over there, like we also have the same scenario of issue that like we gonna, bundle size of around 9 megabytes or like 10 megabytes of data. We used to download every time when the website loads. So we're using Webpack, to bundle all the size. And somehow, we didn't figure out like a way, but we are going back to, our normal stage that, dividing entire components and features, everything into like singular chunks and hosting them separately and then, doing that. Does Walibot does helps us like over there, like maybe?
So Walibot in the end is just a simple JavaScript or TypeScript library. And with its modular architecture, it basically allows a bundle like Webpack to split things and to tree shake things. But we are not on control what your bundle or your build process is doing with it. But compared to other libraries, we at least allow that, for example, tree shaking until kind of the maximum is possible.